Welcome back. Let's talk about Git basics. Welcome back. Let's talk about Git basics. So, local computer. Git thinks of its data more like a set of snapshots. It's like a mini file system. Every time you commit or save the state of your project in Git, it basically takes a picture of what all your files look like at that moment and stores a reference to that snapshot. Or you may think that that's going to be too much effort, but to be efficient, if files have not changed, Git doesn't store the file again. It just link it to the previous identical file it has already stored. So if you look at the picture here, this is going to be checkings over the time, and you have different versions 1 to 5. And at the very beginning, we have A, B, and C. Let's say we're going to change A to A1, we don't change B, and we change C to C1. Then this is going to be a new version 2 for our files. Actually, Git is going to track all of these, and we can see all of these versions, A, A1, B, C, and C1 in our history, and we can go through them and we can review them. And after that, let's say we keep A1, we keep B also, and we're going to change C1 to C2, and then we have a new version 3, A1, B, and C2. In next step, we are going to change A1 to A2, B to B1, and we keep C2, we don't touch C2. Then we have a new version 4, A2, B1, and C2. And in the last state, we're going to keep A2, change B1 to B2, and change C2 to C3. Then this is going to be our last version. As we said before, Git is going to keep everything local. This means most operations in Git only need local files and resources to operate, which is pretty awesome. Generally, no information is needed from another computer on your network. If you're used to a CVCS or centralized version control system, where most operations have that network latency overhead, this aspect of Git will make you think that the gods of speed have blessed Git with unworldly powers, because you have the entire history of the project right there on your local disk. Most operations seems almost instantaneous. Another thing is Git has integrity, and you may say, what is this mean? So everything in Git is checksum before it is stored and is then referred to by that checksum. This means it's impossible to change the contents of any file or directory without Git knowing about it. This functionality is built into Git at the lowest levels and is integral to its philosophy. You can't lose information in transit or get file corruption without Git being able to detect it. The mechanism that Git uses for this checksumming is called a Sha-1 hash. This is a 40-character string composed of hexadecimal characters, and you know what is hexadecimal, 0 to 9 and A to F, and calculated based on the contents of a file or directory structure in Git. A Sha-1 hash looks something like this, and I'll show you in the lab when we are working with the Git. So let's get more information related to Git. You, as someone that want to work with Git, should know that Git has 3 states, and these main states that your file can reside in, they are committed, modified, and staged. Let's see what are these terms. First of all, committed, or when you commit your code, it means the data is safely stored in your local database. It is stored and it's done. If it's modified, it means that you have changed the file but have not committed it to your database yet. Another step is staged, and it means that you have marked a modified file in its current version to go into your next commit snapshot. Look at this picture and I'll explain more. We have the working directory. This is the working directory. Let's say you are going to change something. When you change something, the file is actually modified, right? So the file is modified and you change something. You need to stage the file before doing anything. So first you have the file, you change it, it's modified now, and then you stage the file. It is in the staging area, ready for the commit. And then if you're sure that this file is correct and everything is fine, then you can commit the code, and the code will end up in the Git directory and in your database. So again, let's say you have the file here, you modify the file, and you're sure that it's correct, and you can stage your file or files, and then after reviewing and making sure that everything is correct and based on whatever you want, then you can commit your code, and then this is going to be in your local database in the Git directory. The Git directory is where Git stores the metadata and object database for your project. This is the most important part of Git, and it is what is copied when you clone a repository from another computer. The working directory is a single checkout of one version of the project. These files are pulled out of the compressed database in the Git directory and placed on disk for you to use or modify. Basically, we'll see this, but whenever you have a project or a repository, let's say in Git, you have a folder called .git, which is a hidden folder, and that .git folder or directory is basically your Git database. And each time, whenever you're working in your working directory, Git is going to extract one latest version for you from that directory into your working directory, and you can use that version, which is the current version, and start modifying it. The staging area is a simple file generally contained in your Git directory that stores information about what will go going to your next commit. It's sometimes referred to as the index, but it's becoming standard to refer to it as the staging area. So basically, whatever you are modifying, it will go to the staging area or to the index file ready to commit. So the basic Git workflow goes something like this. Let's review it again. You modify files in your working directory. So you stage the files, adding snapshots of them to your staging area. You do a commit, which takes the files as they are in the staging area and stores that snapshot permanently to your Git directory. If a particular version of a file is in the Git directory, it's considered committed. If it's modified but has been added to the staging area, it's a stage. And if it was changed, since it was checked out but has not been staged, it's modified. So if you can compare with the picture up here, you can easily understand what's happening. Working directory, staging area, and the Git directory. So that was the Git basics, and I hope you enjoyed this tutorial, and I'll see you in the next one.